The topic of the video is digitalization and automation of project management, recent advances in methods, technologies, algorithms, programming and applications. Project management is fundamental to economic development, technological innovation and organizational success. Almost every major human endeavor, from constructing buildings, hospitals and transport infrastructure to developing software, establishing businesses, organizing tourism services, implementing renewable energy systems and conducting major research programs, is undertaken through projects. At the same time, artificial intelligence, AI, AI agents, digital twins, robotics, computer vision, cloud and edge computing, data centers, quantum computing and AI-assisted programming are creating entirely new ways of planning and delivering projects. The convergence of these technologies with project management is producing an important transition from conventional project management towards digital, intelligent and increasingly automated project management. Digitalization is not simply replacing paper documents with electronic files. It involves redesigning the project management system so that data, algorithms, software and intelligent technologies continuously support planning, forecasting, optimization, monitoring and decision-making. Project management. Project management is the systematic process of defining, planning, organizing, executing, monitoring, controlling and completing a project to achieve specified objectives within constraints. The principal dimensions normally include scope, time, cost, quality, resources, procurement, risk, communication, stakeholders, sustainability. Traditional project management uses methods such as work breakdown structures, Gantt charts, critical path method, program evaluation and review technique, earned value management, resource scheduling, budgeting and risk registers. Different projects require different management models. Waterfall approaches are appropriate where requirements and stages can be clearly specified. Agile methods allow iterative development and rapid adjustment. Lean project management emphasizes waste reduction and value creation. Hybrid approaches combine structured planning with flexible implementation. These methods remain important. However, digital technologies can make them more dynamic, integrated and data-driven. Digitalization of project management. Digital project management integrates conventional project management principles with data, software, automation, analytics and intelligent technologies. In conventional management, project information may be collected manually and analyzed periodically. Managers often discover problems after they have already affected project performance. Digital systems can create a more continuous management cycle. Data collection, right pointing arrow integration, right pointing arrow analysis, right pointing arrow prediction, right pointing arrow optimization, right pointing arrow decision, right pointing arrow action, right pointing arrow feedback. For example, instead of manually preparing a weekly progress report, information can be collected from project software, financial databases, IoT sensors, cameras, drones, enterprise systems and digital models. Dashboards can automatically compare actual and planned performance. Machine learning algorithms can estimate the probability of delays. Optimization algorithms can identify alternative resource allocations. AI agents can potentially investigate problems and recommend responses. Digitalization therefore moves project management progressively from descriptive management, what happened, to predictive and prescriptive management, what will happen and what should we do. Automation takes this transformation further by enabling selected activities to occur with limited manual intervention. Emerging technologies and their importance to the world and mankind. Emerging technologies are increasingly important to economic development and improvements in human life. AI, robotics, autonomous systems, digital twins, quantum technologies, advanced computing and intelligent software have applications across healthcare, engineering, infrastructure, business, manufacturing, energy, water, agriculture, education, tourism and humanitarian operations. Their importance lies partly in their capacity to address complexity. Modern societies operate extremely complicated systems involving millions of interactions between people, organizations, physical infrastructure, machines and information systems. Humans alone cannot continuously analyze every variable. Emerging technologies can complement human capabilities by processing large data sets, recognizing patterns, modeling complex systems, predicting outcomes and optimizing decisions. Project management is an ideal area for these technologies because projects involve precisely these problems: complexity, uncertainty, limited resources, competing objectives, and continuous decision-making. Digital project management with emerging technologies, different methods and models. Recent project management systems increasingly combine traditional methods with data-driven and computational models. Critical path method can be dynamically updated when project conditions change. Earned value management can be connected to real-time cost and schedule databases. Agile and lean approaches can use digital collaboration platforms and automated performance measures. Mathematical optimization provides another important foundation. A project may seek simultaneously to minimize cost plus duration plus risk plus environmental impact, while satisfying constraints involving resources, precedence relationships, contractual requirements, and technical specifications. Linear programming, mixed integer programming, genetic algorithms, particle swarm optimization, and other optimization methods can help identify high-quality solutions to these complex problems. AI can extend these approaches by learning from previous projects and continuously updating forecasts. Uncertainty and risk analytics projects operate under substantial uncertainty. Activity duration, labor productivity, material costs, weather, demand, supply chains, technology performance, and market conditions can all vary. Monte Carlo simulation provides an important quantitative technique. Instead of assuming one project duration or cost, uncertain variables are represented using probability distributions. Thousands of possible project scenarios can then be simulated. Managers can estimate questions such as, what is the probability of completing on time? What is the probability of exceeding the budget? How much contingency is required? Which risks have the greatest impact? Machine learning can analyze historical and current data to detect patterns associated with project failure, delays, or cost overruns. The combination of AI plus probability modeling plus simulation plus real-time data creates the possibility of continuously updated project risk systems. Computer vision, robots, drones, and reality capture. Computer vision allows AI systems to analyze photographs and videos automatically. Applications include progress monitoring, quality inspection, defect detection, safety monitoring, and asset identification. Drones can survey large sites rapidly, inspect difficult locations, and generate high-resolution project information. Reality capture technologies such as photogrammetry and laser scanning can produce detailed three-dimensional models of physical environments. These technologies enable comparison between planned project right-pointing arrow, actual physical project robots, extend automation into physical project activities. Inspection robots, construction robots, warehouse robots, and autonomous vehicles can increasingly communicate with digital management systems. Consequently, project management software can become directly connected to physical project execution. Cloud computing, edge computing, and data platforms. Cloud computing provides scalable storage, computing, and software resources accessible across project organizations. Project schedules, documents, costs, contracts, engineering information, and operational data can be stored within shared digital environments. Edge computing complements cloud computing by processing information close to its source. For example, a camera detecting an immediate safety hazard should not necessarily send all video information to a distant cloud server before responding. An edge computer can analyze the information locally. Future project architectures will increasingly combine edge computing plus cloud computing plus AI plus central data platforms. This enables both rapid local responses and large-scale organizational analytics. Data centers. Data centers provide the physical computational infrastructure supporting much of digital project management. Cloud platforms, AI models, digital twins, simulation systems, and large databases ultimately require computing, networking, and storage infrastructure. Project management organizations can use third-party data centers and cloud data centers rather than developing all computational infrastructure internally. Data centers can support AI computation, project databases, digital twin simulations, large engineering models, video analytics, backup and disaster recovery, cybersecurity, real-time analytics. Data centers therefore represent an important enabling infrastructure behind digitalization and automation. Digital twins provide dynamic digital representations of physical systems, assets, organizations or processes. A project digital twin can integrate information from schedules, engineering models, sensors, costs and physical project activities. Unlike a static model, a digital twin changes as the physical project changes. This allows project managers to simulate alternative scenarios before implementing decisions. For example, what happens if construction is delayed by 2 weeks? What happens if an alternative supplier is selected? What happens if additional equipment is introduced? Digital twins can therefore become experimental environments for project management decisions. AI agents and multi-agent systems. AI agents represent one of the most important recent developments. An AI agent can potentially perceive information, reason about a problem, develop a plan, use software tools and execute authorized actions. A future project may employ multiple specialized agents: planning agent, scheduling agent, cost agent, procurement agent, risk agent, quality agent, safety agent, documentation agent. These agents could form a multi-agent project management system. Suppose the scheduling agent predicts a delay. It could communicate with the resource agent to investigate additional resources. The procurement agent could evaluate supplier implications. The cost agent could calculate additional expenditure. The risk agent could compare alternatives. The project manager could then receive an integrated recommendation. This moves AI from being simply an analytical tool towards becoming an active project management collaborator. Quantum computing. Quantum computing is another emerging technology with potential long-term project management applications. Many project management problems involve extremely difficult optimization tasks. Examples include complex scheduling, resource allocation, supply chain optimization, portfolio optimization, logistics, multi-objective decision-making. Quantum algorithms such as quantum annealing and the quantum approximate optimization algorithm can be investigated for these problems. Quantum machine learning may eventually contribute to complex forecasting and risk analysis. At present, practical quantum advantage for routine project management remains largely a research question. However, hybrid classical quantum computing provides an important area for experimentation and future development. Programming provides the foundation for customized digital project management systems. Python is particularly valuable for AI, machine learning, optimization, simulation, automation and data analytics. SQL supports project databases. JavaScript supports web-based dashboards and interactive applications. C and C++ support high-performance computing, IoT devices, robotics and real-time systems. Programming enables organizations to connect different software packages through APIs and automate repetitive workflows. The future project professional does not necessarily need to become a professional programmer, but understanding computational thinking and programming increasingly provides a major professional advantage. AI-assisted programming, coding and software engineering. Generative AI is changing software engineering itself. AI-assisted programming systems can generate code, identify errors, create tests, explain existing software, produce documentation and help develop complete application prototypes. This has major implications for project management. Project professionals may increasingly be able to describe a required application in natural language, for example, a project risk dashboard or automated cost analysis tool, and use AI-assisted programming to help develop it. AI can assist across the software lifecycle: requirements, right-pointing arrow design, right-pointing arrow coding, right-pointing arrow testing, right-pointing arrow deployment, right-pointing arrow maintenance. This could dramatically reduce the time and cost required to create specialized project management software. Human validation remains essential, particularly for safety-critical, financial, legal and engineering applications. Towards intelligent and autonomous project management. The convergence of these technologies points towards intelligent and autonomous project management. The evolution can be viewed approximately as Manual project management, right pointing arrow. Digital project management, right pointing arrow. Data driven project management, right pointing arrow. AI assisted project management, right pointing arrow. Agentic project management, right pointing arrow. Selectively autonomous project management. Future systems could continuously monitor projects, update digital twins, predict problems, simulate alternatives, optimize decisions, and automatically execute authorized actions. An intelligent project management architecture could integrate sensors plus computer vision plus drones plus robots plus cloud, edge computing plus data centers plus digital twins plus AI plus optimization plus AI agents plus human leadership. Automation should not mean eliminating human responsibility. Major projects involve ethics, safety, contractual responsibilities, stakeholder relationships, and strategic judgment. Human accountability remains essential. Instead, intelligent automation can free project managers from repetitive data collection, reporting, and routine administration, enabling them to concentrate on leadership, innovation, negotiation, and strategic decisions. Digital project management applications across disciplines. Digital project management has applications across virtually every sector. In building and construction, it supports planning, BIM, procurement, construction monitoring, cost control, and facility management. In engineering and manufacturing, it can integrate design, simulation, production, robotics, and supply chains. In business, digital project management supports product development, organizational transformation, mergers, marketing programs, entrepreneurship, and technology implementation. In information technology, it supports software development, cybersecurity, AI implementation, and cloud transformation. In healthcare, it can support hospital projects, medical technology implementation, research, and digital health programs. In energy and water, it can support renewable energy, utilities, treatment plants, and major infrastructure projects. The tourism industry also provides significant opportunities. Tourism organizations manage hotel developments, events, destination development projects, transport services, marketing campaigns, and visitor experiences. AI can forecast tourism demand. Digital twins can model destinations and facilities. AI agents can coordinate bookings, resources, and customer services. Computer vision can analyze visitor flows. Cloud systems can integrate tourism operations, while risk analytics can support event and destination planning. Digital project management therefore extends far beyond engineering. It is becoming a multidisciplinary capability for managing complex activities throughout modern economies. Conclusion: digitalization and automation are fundamentally changing project management. Traditional methods remain important, but they are increasingly being strengthened by mathematical optimization, uncertainty modeling, Monte Carlo simulation, computer vision, drones, robotics, cloud and edge computing, data centers, digital twins, programming, AI-assisted software engineering, AI agents, and potentially quantum computing. Together, these technologies enable a transition from periodic and reactive management towards continuous, predictive, prescriptive, intelligent, and increasingly autonomous project management. The greatest opportunity is not simply to automate existing project management practices. It is to redesign project management itself. Future project management systems may continuously sense what is happening, understand why it is happening, predict what is likely to happen, determine alternative responses, and autonomously perform selected actions under appropriate human supervision. Across construction, engineering, business, tourism, healthcare, manufacturing, energy, water, IT, and many other disciplines, this transformation offers significant opportunities to improve productivity, cost efficiency, sustainability, safety, innovation, decision-making, and project success. The future of project management will therefore increasingly combine human leadership with digital intelligence, bringing together people, data, algorithms, programming, AI agents, and emerging technologies to deliver complex projects more intelligently and effectively for businesses, industries, and society. If you enjoyed this discussion, don't forget to subscribe, like, and share. Stay tuned for more insights on AI, quantum computing, and emerging technologies shaping the future of software and humanity.